Imagine the sun, a blazing ball of fire, suddenly disappearing from the sky. The world plunges into an eerie twilight. This is a solar eclipse, a celestial spectacle that has fascinated humanity for millennia. A solar eclipse occurs when the moon passes between the sun and Earth, casting a shadow on our planet. For a brief period, the moon blocks the sun's light, creating a breathtaking celestial ballet. A solar eclipse is not just a visual treat, it's a testament to the precise movements of celestial bodies. It's a reminder of our place in the vast cosmos, where even the most massive objects obey the laws of gravity. The alignment of the sun, moon, and Earth is a rare event, making solar eclipses a truly special phenomenon. Not all solar eclipses are created equal. Each type offers a unique and fascinating experience for observers. There are three main types: total, partial, and annular. Each type is defined by the extent to which the moon covers the sun. Astronomer. A total solar eclipse occurs when the moon completely covers the sun, creating a total blackout. This is a rare and awe-inspiring event. This happens when the moon is at its closest point to Earth in its orbit, known as perigee. The sky darkens dramatically, stars become visible, and the sun's corona, a halo of plasma, becomes visible to the naked eye. It's a breathtaking sight. A partial solar eclipse occurs when the moon only partially covers the sun. This type of eclipse is more common and can be seen more frequently. This type of eclipse is more common than total eclipses, making it more accessible for many people to witness. During a partial eclipse, the sun appears as a crescent, as if a bite has been taken out of it. The shape and size of the crescent can vary. The amount of the sun that is covered by the moon varies depending on the observer's location. Some areas may see a larger portion covered than others. Astronomer. An annular solar eclipse occurs when the moon is at its farthest point from Earth in its orbit, known as apogee. Because the moon is farther away, it appears slightly smaller than the sun. This size difference creates a unique visual effect. As a result, the moon doesn't completely cover the sun, leaving a bright ring of sunlight visible around the moon's silhouette. This phenomenon is often referred to as the Ring of Fire. This Ring of Fire is a spectacular sight to behold. It offers a different kind of beauty compared to a total eclipse, making it a must-see event for sky watchers. Why don't we experience a solar eclipse every month? It's a question that often puzzles many. The answer lies in the intricate dance of orbits, a celestial ballet that is both fascinating and complex. The moon orbits Earth, and Earth orbits the sun, creating a dynamic system of motion. However, the moon's orbit is not perfectly aligned with Earth's orbit around the sun. This misalignment plays a crucial role. Instead, it is tilted at an angle of about 5 degrees, a small but significant tilt. This tilt means that most of the time, the moon's shadow misses Earth, preventing a solar eclipse. Only when the sun, moon, and Earth align perfectly, or nearly perfectly, do we experience a solar eclipse. This alignment is a rare celestial event. This alignment doesn't happen very often, which is why solar eclipses are relatively rare events. They are special moments in our sky. Student, media, moon's elliptical orbit around Earth. The moon's orbit is also slightly elliptical, meaning that its distance from Earth varies. This elliptical path adds another layer of complexity. This variation in distance affects the type of solar eclipse that we see, influencing whether it is total or annular. When the moon is closer to Earth, it appears larger and is more likely to cover the entire sun, resulting in a total eclipse, a breathtaking sight. When the moon is farther from Earth, it appears smaller and is more likely to produce an annular eclipse, where a ring of the sun remains visible. For centuries, solar eclipses were met with a mixture of awe and fear. People would gather in open fields, staring at the sky in wonder, unsure of what was happening. Ancient civilizations often interpreted them as omens or signs from the gods. They believed these celestial events could predict the future or signal divine displeasure. However, with the advent of astronomy, we have come to understand the science behind these celestial events and can now predict them with remarkable accuracy. This shift from superstition to science has been monumental. Astronomers use complex mathematical calculations to determine the paths of the sun, moon, and Earth. These calculations involve intricate models and simulations. By taking into account the moon's elliptical orbit, Earth's rotation, and other factors, They can pinpoint the exact time and location of future eclipses. This precision is a testament to human ingenuity and our quest for knowledge. These predictions are essential for scientists and eclipse chasers alike, allowing them to plan expeditions and gather valuable data. This data helps us understand not just eclipses, but also broader astronomical phenomena. These advancements have transformed our understanding of solar eclipses, turning what was once a source of fear into an opportunity for scientific discovery. Today, solar eclipses are celebrated events, bringing together communities and scientists in a shared experience of wonder and learning. Section 5. Unveiling the Corona.
Solar eclipses provide a unique opportunity to study the sun's corona, the outermost layer of its atmosphere. The corona is a region of extremely hot, ionized gas that extends millions of kilometers into space. Normally, the corona is invisible to us because it is outshone by the sun's bright surface. However, during a total solar eclipse, the moon blocks the sun's bright disk, revealing the ethereal glow of the corona. This allows scientists to study the corona in detail, using instruments to measure its temperature, density, and magnetic field. Understanding the corona is crucial for predicting space weather, which can impact satellites, power grids, and even our daily lives.
Section 6. A glimpse through time.
Solar eclipses have played a significant role in shaping human history and culture. Ancient civilizations often incorporated eclipses into their mythology and religious beliefs. For example, in Chinese mythology, a solar eclipse was believed to be caused by a celestial dragon devouring the sun. Eclipses have also been used to date historical events. By comparing ancient records of eclipses with modern astronomical calculations, historians can pinpoint the exact dates of past events. For example, a solar eclipse recorded by the ancient Greek historian Herodotus helped to date the Battle of Halys, which took place in 585 BC.
Section 7. Eclipses and Science.
Solar eclipses are not just historical curiosities, they continue to be valuable tools for scientific discovery. In 1919, a total solar eclipse provided the first experimental confirmation of Albert Einstein's theory of general relativity. Einstein predicted that the gravity of the sun would bend the path of starlight passing near it. During the eclipse, astronomers observed that the positions of stars near the sun were slightly shifted, just as Einstein had predicted. This observation revolutionized our understanding of gravity and cemented Einstein's place in the pantheon of scientific giants.
Section 8. Protecting your eyes. Observing a solar eclipse can be an unforgettable experience, but it's crucial to do so safely.
The sun emits intense radiation, including ultraviolet and infrared radiation, which can burn the retina at the back of the eye.
Regular sunglasses, even very dark ones, do not provide adequate protection.
Looking directly at the sun, even during an eclipse, can cause serious and permanent eye damage.
Never look directly at the sun without proper eye protection.
To safely view a solar eclipse, you must use special-purpose solar filters, such as eclipse glasses or solar viewers.
Section 9. Observing indirectly. If you don't have eclipse glasses or solar viewers, there are still safe ways to observe a solar eclipse indirectly.
One simple method is to create a pinhole projector. To do this, poke a small hole in a piece of cardboard or paper and project the sun's image onto a white surface, such as a wall or a piece of paper.
Another safe method is to use a mirror to project the sun's image onto a wall or other surface. Cover the mirror with a piece of paper or cardboard with a small hole in it. Do not look directly at the sun's reflection in the mirror. Section 10. Upcoming eclipses. Mark your calendars. There are many exciting solar eclipses coming up in the next few years.
On April 8th, 2024, a total solar eclipse will be visible across Mexico, the United States, and Canada. This eclipse will be particularly spectacular because it will pass over several major cities, including Dallas, Indianapolis, and Cleveland.
On August 12, 2026, another total solar eclipse will grace the skies, this time visible across Greenland, Iceland, Spain, and Portugal. This eclipse will be notable for its long duration of totality, with some locations experiencing over 2 minutes of darkness. Section 11. Conclusion. Embracing the cosmos. Solar eclipses are a testament to the wonders of the cosmos. They remind us of the intricate dance of celestial bodies and the power of gravity. As we gaze upon these celestial spectacles, we are reminded of our place in the vast universe and the importance of scientific exploration. Whether you are a seasoned astronomer or a casual sky watcher, solar eclipses offer a unique opportunity to connect with the cosmos. So, mark your calendars, protect your eyes, and prepare to be amazed by the next solar eclipse that graces our skies.